Lifesavers, and welcome back to my channel. My name is Nurse Kelly Tyrrell, and in today's video we are going to be covering some NCLEX style calculations questions. And this is actually going to be part 1 of 2, so make sure you tune in tomorrow to catch part 2 of this video. Before we jump into it, make sure you subscribe to my channel, like, comment, and share this video with a friend, and make sure you click that bell icon to turn on notifications so you don't miss out on my upcoming content. If you're not a nursing math whiz and want to brush up on your conversions and calculations, I suggest that you keep watching. All right, let's ease our way into some calculations questions with a fairly easy and straightforward drop factor problem. So the question reads, a client is receiving 1 liter of 0.9% sodium chloride intravenously to be infused over 12 hours. The IV infusion set has a drop factor of 15 drops per milliliter. How many drops per minute will the nurse set the IV to infuse at? Record your answer using a whole number. So this is a very common type of question that you'll see as a nurse. So I want you to be familiar with the drops per minute formula, which is ml per hour divided by 60 minutes per hour times the drop factor. Okay, so let's set up our problem by first picking out the key data points and simplifying the order so we can plug the numbers into our formula. First, let's find our volume and make sure it's converted to our desired unit, which for this formula is going to be milliliters. Our solution volume in this problem is 1 liter. We don't really care about the 0.9% sodium chloride, so don't let the 0.9% throw you off. We're not going to do anything with that number at all. It doesn't matter if it's normal saline or lactated ringers or D5W, it could be any one of those, but what we are really focused on is the actual volume of the bag of fluid. So we have a 1 liter bag of normal saline, but we need milliliters according to our formula, not liters. So now if you memorized your handy dandy metric table, you would know that 1 liter equals 1,000 mLs. So that is the number that we are going to be working with in this problem. All right, so now that we have our total volume to be infused, which is 1,000 mLs, next we need to figure out how many mLs are going to be infused in 1 hour. So the order reads 1 liter or 1,000 mLs over 12 hours. But according to our formula, we need to know how many mLs per hour need to be infused, not 12 hours. So to figure this out, it's really simple. We're gonna take our 1,000 ml and divide that by 12 hours, which will get us our ml per hour. So 1,000 divided by 12 is 83 mLs per hour. Okay, so now that we have figured out what our ml per hour is, we can plug those numbers into our formula along with our drop factor. So our problem is going to look something like this. Drops per minute equals 83 ml per hour divided by 60 minutes per hour times our drop factor, which is 15 drops per ml. So when we do the math, 83 divided by 60 is 1.38 times our drop factor 15 gives us a total of 20.7 drops per minute. Now we have one last step, but it's a crucial step, and that is to round our drops per minute to the nearest whole number, since that is what the problem is asking for. You want to pay really close attention when you're taking your exam as far as what they want the final answer to be rounded to. Is it to the nearest whole number, to the nearest tenth, to the nearest 100th? If you're not rounding at the end to what the question is asking, then unfortunately your answer is going to be marked wrong, so you don't want to do that, so make sure you're paying attention. Okay, so 20.7 rounded to the nearest whole number would be 21, since the number in the 10th place is greater than 5. So our final answer is going to be 21 drops per minute. All right, so let's take a look at another common formula question. So the question reads, the nurse is caring for a 15-year-old who has suffered full thickness burns to 30% of her body. The healthcare provider has prescribed morphine 0.5 milligrams by mouth every 3 to 4 hours as needed for pain. The elixir comes in 2 milligrams per ml. How many milliliters will the nurse administer per dose? Record your answer using 2 decimal places. Okay, so let's start with the formula we're going to be using for this question. So the formula that we need to use is dose on hand over the quantity on hand which will equal the desired dose over X. So for this formula, we're going to do some cross multiplying to solve for X, which in this case is going to be our total mLs. Okay, so let's weed through the question and pick out our key numbers that we need to plug into our formula. Again, we're going to ignore irrelevant numbers that are placed in the question to throw you off. Like for example, a 15-year-old and burns on 30% of her body in every 3 to 4 hours. So this question is looking for X ml, so it doesn't matter how old she is or what percentage of burn she has on her body and the frequency of the medication. None of those will help us solve for X in this question. So we are going to not get thrown off by those numbers. We're just going to put those off to the side for now. All right, so let's identify our dose and quantity on hand. So in order to find the dose and quantity on hand, you're going to look for keywords like the medication comes in, or the package reads, or the pharmacy sent you, or it might say the dose is supplied in. So look for those key phrases to determine your dose and the quantity on hand. So for this question, it states the elixir comes in 2 milligrams per ml. So that's going to be our dose and the quantity on hand that we will need for our formula. So next we're going to find our desired dose. So to find this, you're going to look for key phrases like the healthcare provider has prescribed or the doctor ordered. Those are going to be the key phrases that are going to help you identify your desired dose, because it's what the doctor desires for you to give to the patient. So in this problem, our desired dose is going to be 0.5 milligrams, and it's going to be over what we are trying to solve for, which is X mLs. Okay, so now it's time to set up our problem, which is going to look something like this. 2 milligrams over 1 ml equals 0.5 milligrams over X. Now we have to get to work cross multiplying. So for cross multiplication, you want to remember bottoms up and left before right. So we're going to start at the bottom and multiply to the opposite side and work left to right. So we're going to take 1 times 0.5 milligrams, which is 0.5, and that will equal 2 times X, which is written as 2X. Next, we need to solve for X by dividing the equation by the number that's in front of the X to cancel it out. So 0.5 divided by 2 equals 0.25, and 2X divided by 2 is just going to give us plain old X. So that leaves us with a final answer of X equals 0.25 mLs. And when we look at our problem, we are supposed to round using 2 decimal places, which works out perfectly because that is exactly what we have. Okay, so now let's look at a slightly more complicated calculation question. So the question reads, a child is admitted to the unit after being treated in the emergency department with gastric lavage for ingestion of a bottle of acetaminophen. The nurse has a prescription to administer N-acetylcysteine 140 milligrams per kilogram stat. The child weighs 15 pounds. The package reads 2 grams per 40 mLs. How many milliliters will the nurse administer? Record your answer to the nearest whole number. All right, so where do we start? Well, we're going to start by breaking up this question into 2 parts. So part 1 is finding out what the total milligrams of N-acetylcysteine we will need to administer, and then part 2 is we're going to convert the milligrams to mLs. Okay, so to find out the total milligrams of N-acetylcysteine, you're going to take the child's weight in kilograms and you're going to multiply it by the ordered dose of 140 milligrams per kilogram. So to convert pounds to kilograms, you're going to take 15 pounds and divide that by 2.2 because there are 2.2 pounds in every 1 kilogram according to our handy dandy metric table. So that leaves us with 6.8 kilograms. So next we're going to take that 6.8 kilograms and multiply it by the ordered dose of 140 milligrams per kilogram. So if we're using dimensional analysis, that would look something like this. 6.8 kilograms over 1 times 140 milligrams over 1 kilogram. So kilograms will cancel out and then we multiply straight across the top and we get 952 milligrams of acetylcysteine. Okay, so now that we know our total milligrams to administer, we have to break down our supplied dose from grams to milligrams because we need the units to match when we plug them into our formula. So to convert 2 grams to milligrams, you're going to multiply by 1,000 because remember there are 1,000 milligrams in every 1 gram. So that means that the supplied dose of N-acetylcysteine is 2,000 milligrams per 40 mLs. All right, so now that we have everything converted and our units are matching, we can plug these numbers into our formula, which for this problem is going to be desired dose divided by the supplied dose times the drug concentration or the total volume of the supplied drug. So now we can set up our problem, which will look something like this. So 952 milligrams divided by 2,000 milligrams times 40 mLs. So 952 divided by 2,000 is 0.476 times 40 gives us a grand total of 19.04 mLs. And if you want to solve this using dimensional analysis, you would set up the problem something like this. So 952 milligrams over 1 times 40 ml over 2,000 milligrams. So the milligrams will cancel out and you multiply across the top, which is 38,080, and then across the bottom, which is 2,000, and then you divide those numbers and you still get a total of 19.04 mLs. So now the last step is to round our answer to the nearest whole number. So our final answer is going to be 19 mLs. And there you have it, easy peasy, lemon squeezy. Make sure you come back around for part 2 of this video coming at you tomorrow. And that concludes the end of this lesson. I hope that you found this information extremely valuable and it made you just a little more confident as you prepare to take your NCLEX or your next nursing school exam. I just want to thank you all again so much, Lifesavers, for tuning in today. My name is Nurse Kelly Tyrrell, and I help nurses feel more confident, increase their test scores, and retain what they don't remember in nursing school. Speaking of, are you a nursing student or soon to be or ready to take your NCLEX? If so, have you joined my online student community yet? If not, then what are you waiting for? The UNursity community is a complete nursing resource hub all at your fingertips. Inside, you can expect to receive coaching, community, and content. You'll get daily coaching with your mobile mentor, me, Nurse Kelly Tyrrell. You'll also receive access to weekly educational videos that you can watch months before they even publish to YouTube. You'll also get exclusive printable digital downloads like worksheets, quizzes, flashcards, infographics, cheat sheets, skills checklists, and more. And if this video helped you in any way, be sure to give it a thumbs up. Also, don't forget to smash that subscribe button and click that notification bell so you don't miss out on my upcoming content. Also, if you can do me a favor and drop me a comment below. Let me know where you're at with your nursing journey. I'd love to just say hi and connect with you. Also, make sure you click that share icon to spread the word and encourage a fellow aspiring nurse. And last but not least, when you are ready to take your NCLEX, be sure to check out my NCLEX and Chill review, where I review detailed test-taking strategies and cover every major topic that you can expect to find on the NCLEX. If you want to have that unfair advantage and pass your NCLEX on your very next attempt, be sure to click the link in the description box below. Not ready to end the study sesh yet? Well, you are in luck, because if you stick around, you can watch more of my videos coming at you in 3, 2, 1. Bye, Lifesavers.